Hello. 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 I think that now I am audible and visible to all of you. Just a second that let me check that everything is working fine or not. Just let me check. Chalo. So, hello everyone. My name is Prakhar Srivastava. I have secured All India third rank in GATE 2016. Then I took admission into IIT Bombay and finally completed my masters from NIDI Mumbai. From past 3 years, I'm teaching on an academy with an experience of teaching approximately 22,000 plus students. So, thank you all for your love and support. The subjects that I deal with is industrial engineering, manufacturing technology, and engineering mathematics. And today we are going to cover up the sheet metal operation part. ठीक है, so currently we are discussing the crash course on manufacturing. That is the most important concept in half the amount of time that is usually taken to complete manufacturing. ठीक है, तो यूजुअली मैन्युफैक्चरिंग को कंप्लीट करने के लिए इन डिटेल मैनर वी रिक्वायर 100 hours ऑफ कोर्स, बट यस आई एम ट्राइंग टू कवर अप रैप इट अप दिस पर्टिकुलर कोर्स विद इन 40 to 50 hours, 40 50 55 hours maximum. But yes, we will be covering 80% of the syllabus, 80% of the syllabus in one go. ठीक है, चलो. So today we are going to cover up in sheet metal. In metal forming there are two parts: sheet metal operation, that is light deformation; heavy metal operation, or you can say bulk deformation, or you can say heavy deformation. Under sheet metal operation, we have seen punching, blanking, bending, and today we are going to cover up the fourth part of sheet metal operation, that is deep drawing. Apart from that, after this deep drawing, we will be starting with the bulk deformation, where the first topic would be rolling operation. ठीक है, चलो. So let me start with the video, but before that, let me take out my books. No. So this is the book that I refer. I have shown you this book many a times. I have shown you this book. This is Production Engineering. This is Production Engineering by PC Sharma. It is an absolutely amazing book because you would be getting some really cool concepts in this. That too in a dedicated manner. That too with numericals. So काफी अच्छी किताब है ये. There are two parts of PC Sharma. That first one is the production technology, and the other one is production engineering. ठीक है. The first one is production technology. The other one is production engineering. Just a second, there is some sound. There are some sounds. I am muting the video for 10 seconds. थोड़ा सा इंतजार करो, 1 मिनट बस, जस्ट अ सेकेंड. एक्चुअली क्या होता है ना, केबल्स बहुत सारी हो जाती है. टू आर लॉट केबल ना. Cool. So let us start with the lecture. I'll come to the subscription pitch afterwards. Once you feel that yes, it is beneficial for you, then we can come back to the subscription pitch. Okay. But apart from that, one small announcement that from 28th of December, mechanical batch A is going to be launched. Mechanical batch A is going to be launched, and I request you to have a look on this batch. If it is on Unacademy Plus platform, and if you want to join Unacademy Plus, you can use the code crack10. That's it. To study from these top faculties, you can use the code crack10. You can use the code crack10. Okay, I'll show you a video also. Just a second, I'll show you a video also. Okay, so since now you have seen the video also, it is clear to you that what all things will be provided, who all will be teaching in this particular batch. If you want to join an Academy Plus, you can join using the code crack10. ठीक है, चलो काम की चीज पे आते हैं. So let us start with metal forming. मेटल फॉर्मिंग इंट्रोडक्शन आई हैव गिवन यू. देखो एक चीज होती है, till yesterday we were discussing about the stage, that is what is the amount of force, power, pressure, what are the different things that are required, for this particular thing, operation. ठीक है, आपने बिल्कुल पता किया था, everything was fine, but many people don't understand that what you actually require. Suppose this is a workpiece, and now you need to change its shape. So you will apply force from here, and the shape will become like this. The shape will become like this. Yes or no? The shape will become like this. Is it clear? But don't you think as soon as you remove this force, it will come back to this position? Yes or no? As soon as you will remove this force, it will try to come back to the original position. Yes or no? This is known as elastic property. But what if we are applying force, the force F that we are applying? What happens if this force that we are applying takes this to the plastic region? Plastic region, you have studied this in stress strain curve, that plastic region is a region in which if the material enters, it will not come back to its original position. Is it clear? So there are certain things that you need to keep in mind. Is it clear? There are certain things that you need to keep in mind, that I have to apply force such that this product goes into plastic deformation phase. So that is why metal forming is always associated with plastic deformation, because I want to change the shape of a particular component permanently. मुझे अभी थोड़े समय के लिए तो करना नहीं है. I need to change the shape of this particular component permanently. I need to change the shape of this component. ठीक है, चलो, that is one very important thing. So what I will do, I need to put this force F. I need to calculate the value of force F such that it goes into the plastic deformation phase. First I will show you what is plastic deformation phase. तो एक stress strain diagram बना लिया जाए गर्मा गर्म. So this is your stress strain diagram. देखो, ध्यान से समझना, बहुत ध्यान से समझना. You are having a component. This is your strain. This is your stress. Initially, for the first part, stress is directly proportional to strain. For this part OA, the part is directly proportional. ठीक है, this is known as the proportionality limit. A will be known as the proportionality limit. Now suppose you are applying this much stress. Amount of stress, suppose say X. As soon as you remove this stress, automatically it will come back to its original shape at O. ठीक है भाई, कोई दिक्कत नहीं है. Beyond this, the graph goes like this. This is known as A dash. Now A dash is what? Between A to A dash, the elastic limit is there. It will again come back to O. But between A and A dash, stress is not directly proportional to strain. That is important. ठीक है? So between A dash, A is known as elastic limit. That it is known as elastic limit. Between A and A dash, the elasticity is followed, but proportionality is not followed. That is very important point. And then the third part is this, that is point B. B is known as upper yield strength. ठीक है. At B, if you apply the stress, if you apply this stress sigma B, ठीक है, if you apply this stress, when you leave it, it will come back to its original shape, but with some deformation, but with some minute deformation, but with some minute deformation, but with some minute deformation, and beyond B, the elastic limit will start. Beyond, sorry, the plastic range will start. It will go up to the point C. C is known as the ultimate tensile strength. Ultimate strength. If you apply the load more than C, if you try to apply the stress more than C, it will break. It will break. It will break. If you are increasing the strength, if you are expanding it more, ठीक है. Strain means change in shape. If you are trying to change the shape much more, it will then break. It will then break and come down. It will then break and this will come down. There is a fracture. There is a fracture. So that is why the zone that is beneficial for us, is this zone. Between B to C, we will be having the plastic range. We will be having the plastic range, and in this range I need to take the product so that it cannot come back to its original shape. Is it clear to all of you? So that it cannot come back to its original shape. Yes or no? Yes or no? This is the range in which I need to take. That is why metal forming is known as the plastic deformation of the object. The plastic, लिख लो. In metal forming, large forces are applied to work material to deform it plastically. So that it cannot come back to its original shape. ये चीज समझ में आ गई? People don't understand what is B. देखो, if you in metal forming, B is the minimum limit or minimum stress that you need to apply, because beyond B only you will enter into the plastic deformation. Yes or no? Beyond B only you will enter into the plastic deformation. So that is why B is the minimum limit. And C is the maximum limit, because if you are applying more force, more stress than C, it will break. So this is your stress strain curve. ठीक है. Now please be careful. Suppose initial length, this is important, many a time this question have been asked in the GATE examination. Initial length is equal to L naught. Final length is equal to LF. Now if somebody asks you what is the value of a strain, what you will say? Change in length upon original length. And what is the value of a stress? Force. Suppose I am engineering stress. And this is known as engineering strain. Till 11th class, this was okay. But now you need to understand something extra. आपको कुछ extra समझना पड़ेगा. Is it clear? Now you need to. ठीक है, थोड़ा extra समझना पड़ेगा आपको. क्या? देखो, please try to understand. Suppose this is my rod that I am pulling. The initial area is A naught. ठीक है, I am pulling with a force F. The area is A naught. After some time, the length will increase, the area will decrease. Obviously, simple. If I am pulling it, the volume remains same. Volume कहाँ जाएगी? Whatever is the material, if I am pulling, you can say the area will decrease, the length will increase. Yes or no? So this is your area final. This is your force F. Yes or no? Your length increased, area decreased. But one very important thing is that Either you can check stress at this point, either you can check stress as at this point, but how can I say that during the whole duration the stress was F upon A naught? No, because at every moment the A naught is decreasing. 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 Yes or no? Obviously yes, sir. Obviously yes. That the area is changing continuously. How can I say that my stress is constant? Stress is directly like inversely proportional to area or directly dependent on area. अगर area ही decrease हो रहा है, don't you think that stress will increase? If area is decreasing, don't you think that stress will increase? Obviously it will increase. Obviously it will increase. Yes or no? If area is decreasing, the stress will increase. So that is why this is not the true stress. This is not the true stress. This is not the true stress. Let us say इंस्टेंटेनियस एरिया किसी भी एक पॉइंट पर रैंडमली अगर मैंने एरिया चेक किया, लेट अस से इट इज ए, तो व्हाट इज द वैल्यू ऑफ सिग्मा एट दिस पॉइंट? एफ डिवाइडेड बाय ए. एफ डिवाइडेड बाय ए. यस और नो? यही आपका स्ट्रेस होगा. दिस वुड बी योर स्ट्रेस. दिस वुड बी योर स्ट्रेस. ठीक है, कोई दिक्कत नहीं है. ए नॉट डिवाइडेड बाय ए नॉट, कोई दिक्कत नहीं. I have just rearranged it. I have just rearranged it. I have just rearranged it. Is it clear? ठीक है भाई, कोई दिक्कत नहीं है. This is, let us say true stress को हम क्या बोल रहे हैं? S. The engineering stress is known as this, and engineering strain is known as small e. Engineering strain is known as small e. Engineering strain is known as small e. ठीक है, देखो अब यहां देखना. This is S. F by A naught is what? S. F by A naught is what? S into A naught by A. A naught by A. A naught by A. Is it clear? Can you write A naught by A naught into L naught is equal to A into L? Yes or no? Instantaneous length is L, so volume remains constant. So A naught by A is equal to L divided by L naught. Can you write it in this manner? L divided by L naught. Can you write it in this manner? L divided by L naught. Yes, obviously you can write it. अब देखो यहां से स्ट्रेन की वैल्यू क्या होती है? व्हाट इज स्ट्रेन? L माइनस एल नॉट डिवाइडेड बाय एल नॉट. ठीक है, strain is shown as E. L by L naught minus 1. Can you say L by L naught is equal to 1 plus E? Yes, you can say that. L by L naught is equal to 1 plus E. ठीक है, L by L naught is equal to 1 plus E. So can you write A by A naught is equal to L by L naught, and L by L naught is nothing but 1 plus E. 1 plus E. ठीक है. So can you write the true stress is equal to the engineering stress into 1 plus E? Can you say that the true stress is equal to engineering stress into 1 plus E? Yes, you can say that. Yes, you can say that. ठीक है. Is it clear? Is it clear? So that is why the engineering strain sigma is given as, sorry, the true strain sigma is given as engineering strain into 1 plus E. Engineering strain into engineering stress into 1 plus engineering strain. Is it clear? ठीक है. Now what is the value of epsilon? That is nothing but true strain. True strain. True strain. तो देखो, change in length upon original length. Change in length upon original length is something that your basic definition of strain says. ठीक है, your basic definition of strain says. ठीक है, L naught to L, L naught टू एल, ठीक है, व्हाट विल बी दिस वैल्यू लॉग ऑफ एल, एल नॉट टू एल, एल नॉट टू एल, एल नॉट टू एल, ठीक है, देखो आगे लॉग ऑफ एल माइनस log of L naught, is it clear? That is log of L divided by L naught, और अभी हमने वैल्यू निकाली थी, what do you mean by L by L naught? Log of 1 plus engineering strain. So true strain is equal to log of engineering strain. अरे भैया क्या किया जाए, जनता बताएगी क्या किया जाए इसके साथ, फटाफट जनता बता दो, मौका दिया जाए पढ़ने का. So I'll write you the summary. The engineering, this is engineering stress. This is given by force upon original area. Engineering strain. This is change in length upon original length, change in length upon original length, ठीक है. फिर उसके बाद सिग्मा, दिस इज ट्रू स्ट्रेस, दिस इज S into 1 plus E, clear, and epsilon, this is true strain, true strain. This is log of 1 plus E. 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 ठीक है, this is log of 1 plus E. So these are the four very important formula. Every year you can say one question comes from true strain. If you know the formula for true strain, you actually don't have to feel anything. You don't have to worry about anything. And these are the basic things. These are very basic things. These are very basic things. Is it clear? And that is why when you try to draw the stress strain curve, देखो यहाँ पर जो stress strain है, this is engineering strain and engineering stress. Now if you try to draw the graph between true stress and true strain, it will look like this. This will be the graph between true stress and true strain. Or true stress. Sigma is equal to K epsilon to the power n. Simple, very simple. ठीक है, कुछ भी नहीं है इसमें, कुछ भी नहीं है. This is a basic diagram between the stress strain curve of true stress strain curve. This is something which was very important. ठीक है, ये आपने कर लिया. Let us move to the next topic. अब फॉर्मूला आपको पता है, you can answer maximum question, you can answer many questions, you don't have to worry about that. You can literally answer most of the questions. ठीक है, चलो give the heading. डीप ड्रॉइंग कर रहे थे ना, डीप ड्रॉइंग कर रहे थे. सो डीप ड्रॉइंग के लिए क्या होता है, द बेसिक थिंग इज दिस, that is you get a blank from a blanking operation and you apply the force in the perpendicular direction, and when you apply the force it gets drawn into a cup. So this whole, suppose the diameter is D, suppose the diameter of this blank is D, suppose the diameter of this blank is D, it is drawn into a cup of diameter small d and height capital H. Is it clear? The blank is drawn into a diameter, the blank is drawn into a cup of diameter small d and height capital H. बिल्कुल सही है भाई, कोई दिक्कत नहीं है, बिल्कुल सही है. Now, if I am applying, this is the area. If I am applying force to draw into a cup, can you say the area of the cup is equal to the area, the internal area of the cup is equal to area of the blank? Yes or no? The area of the cup is equal to the area of the blank. That you can say or not? Yes, obviously you can say that. If you can say that, then if you can say this thing, then देखो, usually क्या होता है, the design department gives you a requirement. Design department gives you a requirement that they want a cup, they want a cup shape object of diameter 10 mm, height 15 mm. Simple. Now it's your responsibility to find out, being a production engineer, it's your responsibility to find out how this part will be made. You know, drawing a cup is easy from a blank. Now your worker will ask, sir, what should be the diameter of the blank? Because then this diameter we will feed into, this diameter we will feed into, this diameter we will feed into the machine, and then we will be getting a blank of this shape and size. Okay, this shape and size. But it is very important, it is your responsibility, being a production engineer, you should tell how I am going to make this cup. Is it clear? So this cup, the requirement will be defined by the design department. But how it is need to be made? What is the force required? What is the dimension of the initial raw material required? What is the dimension of the initial raw material required, and what is the force required? That you need to get. Okay. So what is the diameter D? Can you say the area of this blank is equal to the area of the cup? Yes, obviously yes. So cup में सबसे पहले तो ये parts हटाओ. This is your cup. Now, very important. Simple. Can you say pi d square is equal to pi dh, that is the curved surface area of cup, plus pi d square by 4. The surface area of the blank is equal to the surface area of the cup. Yes or no? So that is why from here you will be getting the value of d as 4dh plus d square root. This is the exact relationship between what should be the diameter of the blank that you are going to use. What should be the diameter of the blank that you are going to use? What should be the diameter of the blank that you are going to use? What should be the diameter of the blank that you are going to use to make a particular cup? To make a particular cup. Is it clear to all of you? Please note it down. ठीक है. सो डीप ड्राइंग में ये आप लिख लो, फिर मैं लिखवाता हूं आपको थोड़ा सा. लिख लो. अब कैसे इसको डीप ड्राइंग कैसे बोलेंगे? Why we are not calling it as shallow drawing, or why we are not calling it as moderate drawing, or why we are not calling it as drawing? Why we are only considering it to be deep drawing? So there is a very simple method. I want you to note it down. The depth of draw may be the depth of draw in bracket write h. The depth of draw in bracket write h. The depth of draw h can be shallow, moderate or deep. Can be shallow, moderate or deep. Or deep. If depth of the cup is less than half the diameter, we will call it to be a shallow drawing. We will call it to be the shallow drawing. And if h exceeds the value, the diameter of the cup, it is known as deep drawing. if the value of h is less than d but more than d by 2, this is known as moderate drawing. So we are considering this, we are studying deep drawing only, because shallow drawing is quite difficult to understand. There are many assumptions in it. Is it clear? So we are considering deep drawing. ये लिख लो, this is important. ठीक है, लिखो. इसके बाद एक हेडिंग लिखो, डीप ड्रॉएबिलिटी. इसके बाद लिखो डीप ड्रॉएबिलिटी. डीप ड्रॉएबिलिटी. डीप ड्रॉएबिलिटी. देखो पढ़ते रहा करो, मैं बता रहा हूं, बिकॉज व्हाट हैपेंस दैट, देखो पढ़ना is one thing, but along with that we are having certain competition also which are having really exciting prizes. So if you are participating in these competitions, you would be really, like, you can literally win some very exciting prizes. For example, on 16th of December we had an Unacademy combat for GATE. ठीक है, for different branches it was there. That is, it is like a quiz competition, and जो prize winners रहेंगे उनको लैपटॉप मतलब you can say MacBook Air, the first prize, the first position will be getting MacBook Air, the second position will be getting iPad mini, then third position will be getting AirPods, top 100 people will be getting 1000 rupees worth Amazon vouchers. So a lot of things are there out there for you. तो पढ़ते रहा करो, ऐसा नहीं है जब एग्जाम आएगा तभी पढ़ना है. You have to win these competitions also. You can really win very cool and exciting prizes. Good evening everyone. I'll just show you the video जो अभी combat हुआ है उसके ऊपर. The combat, it is already up, it is already over. I'm just showing you कि these competition continuously takes place.
It's time to experience something glorious. Unacademy Combat. Compete, crack, conquer.
A challenging GATE contest engineered to give you an experience like none other.
Where you put your knowledge to test
and battle it out with the best.
To bring out the best in you, Unacademy Combat is the most competitive, gamified contest for GATE till date, with the best of the questions by best educators.
with detailed video solutions from top educators right after each contest.
Combat live with peers to get real-time rankings and win big.
Participate in every contest to improve your ratings.
Challenging contests every fortnight or alternate Sunday. Live ranking after every question. Big rewards for top rankers. Your passion to crack GATE deserves this. Your hard work towards your dream deserves this. Fuel your inner fire for the ultimate GATE challenge. Unacademy Combat. Register now.
So, have you seen it? So this is not one-time competition. It is going to happen again and again, and based on your performance, your ranking, your score will increase. Okay, so that is why if you have missed the first part, I would request that please get ready for the upcoming combat competitions and don't miss any class. Practice as many questions as you can. If you are having any doubt, please ask in the comment section. Okay, chalo. Let us move forward. Let us move forward. Chalo. Give the heading deep drawability. It is also known as drawing ratio. It is an important term. ऐसा कोई छोटा term नहीं है. Please write it down. This is also known as drawing ratio. Drawing ratio आपने बहुत बार सुना होगा. If you have not liked the video, please do like the video, guys. Please do like the video. अगर आपने नहीं देखा है तो जरूर like करें वीडियो को. लिखो. It is defined as maximum blank diameter. It is defined as the ratio of maximum blank diameter to the diameter of the cup drawn from the blank. To the diameter of the cup drawn from the blank. To the diameter of the cup drawn from the blank. To the diameter of the cup drawn from the blank. लिखो, for a material, for a given material, there is a limiting draw ratio. Beyond, देखो ऐसा नहीं है that 10 mm, like you can say 1000 mm sheet blank is there, you can reduce it to a diameter of 10, a cup of size 10 mm diameter, and you can say very long height. No, you cannot do that in one go. There is a limitation that you can decrease. For example, suppose this is 500 mm. You cannot convert it into this shape, a cup of this size, this type. You cannot cover it up into a cup that is, this is 5 and this is something, say jo bhi hoga according to the volume. Suppose say this is 100. Is it clear? Suppose say this is 100. So this is something you need to understand, that you cannot get any size and shape, of cup. There is a limiting draw ratio, that is the 500 mm blank can only be converted into a cup which is 200 mm in diameter, and then this cup will further reduce to a cup which is 100 mm in diameter, and slowly you will reach up to the value of 5. In one go you cannot do that. That is what the limiting draw ratio is. That is what the capability of the system is. Likho. For a given material, there is a limiting draw ratio depending upon many factors. Limiting draw ratio depending on many factors. ठीक है, सिंपल. ड्रॉएबिलिटी आपको पता चल गई. लिखो, डिजाइन कंसेंट्रेशन. गिव द हेडिंग डिजाइन कंसिडरेशन, कि आपको डिजाइन करते समय क्या क्या ध्यान में रखना है. डिजाइन कंसिडरेशन, क्या क्या कंसिडर करना है while designing die, what you need to consider, and then you will understand while designing punch what you need to consider. तो लिखो die में लिखो, the edge radius of the first draw die, the edge radius of the first draw die over which the blank is drawn, it is very important. It is very important. If the radius, अगर आपका die का radius छोटा हो गया, if your die radius is very small, if the die, लिख लो, it is very important. If the die radius is small, the resistance to the flow of metal increases. Resulting in cutting or tearing of metal. On the other hand, if the radius of die is too large, it may lead to the formation of wrinkles. That is why die diameter has to be optimum. Therefore, the die diameter has to be optimum. इसके बाद देखो पंच में, डिजाइन कंसिडरेशन while drawing the punch. लिखो, the edges of the punch should be rounded. To avoid cutting or tearing of metal. ठीक है. And एक्सेसिव पंच रेडियस, अगर बहुत ज्यादा हो गया पंच रेडियस तो क्या करोगे, तो लिखो एक्सेसिव पंच रेडियस increases the tendency of the material to buckle, increases the tendency of the material to buckle, increases the tendency of the material to buckle. ठीक है, कम ज्यादा डाई रेडियस कम ज्यादा करेंगे तो क्या होगा ये भी पता चल गया, पंच रेडियस कम ज्यादा करेंगे तो क्या होगा ये भी पता चल गया। ठीक है, लिखो एक जरूरी चीज रहती है, एक जरूरी फॉर्मूला मैं आपको बता दूं कि काम का फॉर्मूला क्या रहता है। सपोज यहां पर आपने फ्लैंज तो कंसिडर किया नहीं है, ठीक है, फ्लैंज क्या होता है वो भी समझ लो। सपोज दिस इज अ ब्लैंक and from this blank a cup shape object is made. So this part is known as flange. Suppose let us say this diameter is d2, this diameter is d1 and this diameter is capital D. अगर आपने flange भी बनाए हैं, if you have made flanges also, then what will be the value, then what will be the value, flanges बनाए हैं then what will be the value। तो देखो ध्यान से देखो, capital D will be given as root over flange diameter है d2 square plus 4d1h। this is very important कि अगर flange भी दिया हुआ है, if the flange is also given, then what you will do and then how you will actually crack the, how will you actually approach the problem, is it clear, how will you actually approach the problem, this is very important, that is what is the size of the blank with flanges, this is really very important, very important। तो आप ये नोट डाउन करो, I'll be just back from washroom। ठीक है, आप लोग करो, I'll be just back from washroom and if you are having any doubt please let me know। then if you don't have any doubt then I think post break, post this, हाँ we will start with rolling operation because जितना करना था वो हमने deep drawing में कर लिया, that's it। if you are having any doubt you can ask, otherwise I'll be starting with the rolling part, that is bulk deformation। ठीक है, I'll be just back from washroom। Okay, so I'm back and let us start with the rolling then. Rolling start की जाए. कोल्ड फॉर्मिंग, हॉट फॉर्मिंग यार एक थ्योरेटिकल टॉपिक है, आप कर लेना, क्योंकि क्रैश कोर्स में वो कराना वैसे पॉसिबल है नहीं. क्रैश कोर्स में मोस्टली हमारा जो टॉपिक चलते हैं वो रनिंग टॉपिक्स चलते हैं, जो 80-90% ऑफ द सिलेबस जो बहुत कॉमनली आता है ना वही चलते हैं. देखो देखो गिव द हेडिंग रोलिंग. आज रोलिंग तरीके से कर लेंगे. लिखो रोलिंग. तो लिखो रोलिंग होता क्या है. सबसे पहले समझो रोलिंग होता क्या है. दिस इज रोल 1 and this is roll 2. You enter the material from this side. This is your material. It get reduced to a smaller thickness and it goes out. It goes out. ठीक है. This is your H1. This is your L1. This is your L2. That is, देखो, if I am decreasing the thickness, obviously the length will increase. Why? देखो दोनों डायरेक्शन में होगा, but I am assuming that this width remains constant. This width remains constant. Whatever is the width at the beginning, suppose this width is W here, the same width will be W here only, here also. यहां पर भी जो width होगी ना वो W ही होगी. Is it clear? ये आपका पूरा एक रोलर हो गया. जस्ट अ सेकेंड, मुझे कंफर्म करना. डिलीवरी का था. ठीक है. देखो अब क्या होता है, दैट दिस इज कांस्टेंट, दैट इज इनिशियली द लेंथ इज L1, द हाइट इज H1, द विड्थ इज W. आफ्टर deformation the length becomes L2, the height becomes H2, this is the cross section. ठीक है. And the width remain constant. Now this is the basic operation of rolling, that is I am reducing the height, increase in the length, there is no change in the width. This is the basic you can say procedure of rolling. This is the basic procedure of rolling. तो लिख लो थोड़ा बहुत लिख लो. In rolling the metal is plastically deformed. In rolling the metal is plastically deformed by passing it between the rolls. The metal is plastically deformed by passing it between the rolls. ठीक है. इसके बाद देखो, मैं आपको एनालिसिस भी दूंगा. नो, W कैन नॉट चेंज, दैट इज एन अजम्पशन. देखो W कैन ऑब्वियसली चेंज, दैट इज नोन एज स्प्रेड. मैं बता रहा हूं, देखो क्या होता है. देयर इज अ टर्म नोन एज ड्राफ्ट. There is a term that is known as draft, H1 minus H2. But suppose there is a change in width, that is known as spread. That is W1 minus W2. But for our analysis, it is an assumption that spread is 0. ठीक है. होने को तो होगा, जरूर होगा. Why not? Why it will not happen? Suppose you are taking a tomato and pressing it like this. will it only get teared in one direction? No, it will go to all the 360-degree direction. Similarly, if I'm pressing the material, it will try to increase in length and increase in width. Both, it will try to change both length and width. It will try to change both length and width, but हम उसमें analysis नहीं कर पाएंगे. So that is why this is an assumption that only the length is increasing and W is constant. Is it clear? That is something you should understand. ठीक है, चलो आगे लिखो. This is very very important, very important. This point is A. This point is A. This point is D. ठीक है, this point is D. चलो लिख लो. ये फिगर बनाओ और लिखो. ड्रॉ दिस फिगर एंड राइट डाउन. देखो, एक छोटी छोटी सी चीजें हैं. द वॉल्यूम बिफोर एंड आफ्टर विल रिमेन कांस्टेंट. V1, sorry, L1, H1, W. This is the volume before, and L2, H2, W. This is the volume afterwards. W and W gets cancelled. You know that H1 is greater than H2 because there is a reduction in height. Can you say L2 will be more than L1? Can you say L2 will be more than L1? Obviously you can say that. इसमें इतनी बड़ी बात क्या है? And now if you divide it by time, if you divide both sides by time, can you say the velocity at 2 is greater than velocity at 1? Can you say the velocity of 2 is greater than velocity of 1? You can obviously say that. This is a very important result. That is, the exit velocity is more than the entry velocity. This is an important result. कैसे आया ये result? Is it clear? That is the exit velocity. V2 is on the right hand side. V1 is on the left hand side. So can you say the velocity of this part V2 and the velocity of this part is V1? ठीक है, V1 is L1 by T, V2 is L2 by T. That is fine. But that is why, can you say that velocity is increasing? So at A, the velocity is V1. At B, the velocity is V2. At A, the velocity is V1. At B, the velocity is V2. This is clear. This is, I don't think that this is going to be a really important part. This is very easy, very easy, and very important. कि होता क्या है? Just a second, I'll open my notes. थोड़ा notes खोल लीजिए because notes are really good. मेरे forming के notes मुझे वैसे भी बहुत ज़्यादा अच्छे लगते हैं because they are easy to understand. Rolling लिख लिया, स्प्रेड लिख लिया, ड्राफ्ट लिख लिया. ठीक है, स्प्रेड ड्राफ्ट सब कुछ लिख लिया आपने, कोई दिक्कत नहीं है. इसके आगे लिखो V2 is greater than V1. इसके बाद देखो, give the heading roll velocity. Give the heading roll velocity. All these things are clear. The third velocity that is included is roll velocity. Suppose rolls are connected to a motor which is running at n RPM. Rolls are connected to the motor. Rolls are connected to the motor that is running at n RPM. So at D, capital D is the diameter of the roll. Capital D is the diameter of the roll. What will be the linear velocity? What will be the linear velocity? The roll velocity VR can set to be pi dn divided by 60. 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 Is it clear? Meter per second. ठीक है. Where diameter is in meter. Diameter D is diameter of roll in meter. जब आप diameter मीटर में डालोगे तभी आंसर आएगा. And n is the RPM of motor. RPM of motor. ठीक है, RPM of roll. Revolutions per minute. अगर revolutions per second दिया then 60 will not come in denominator. If diameter is given in mm, you have to convert it into meter. Is it clear? So this is the basic formula that you should know. This is the roll velocity. This is the formula for the roll velocity. Now what will happen? This part will come in, and suppose say this is your roll. Now please understand, this roll is revolving in this direction, so it will engage the material in the downward direction and throw the material from this side. Is it clear? So at here the velocity is v1. Vr is more than v1. That is, velocity of the roll is more than v1. So that is why Vr is more than v1. And one very important thing is there. V1 and it will throw. So obviously, if you are running and you are throwing something, obviously the resultant velocity of the part that you have thrown will be more than your own velocity, because the part was initially at that velocity only. So that is why the material will come from V1, it will go up to the value of Vr, and then Vr throws the material outward. So that is why the velocity further increases. So that is why V2 is more than Vr. So if you try to establish the relationship between the three velocities, it will be V1, more than V1 is Vr, and more than Vr is V2. More than Vr is V2. More than Vr is V2. More than Vr is your V2. Is it clear? This is an important relationship. Many a time it has been asked in small examinations. Many a time it has been asked in the small examination कि क्या relationship होता है तीनों के बीच में, क्या relationship होता है तीनों के बीच में, ठीक है? तो there are three zones. Suppose Vm is the velocity of material. So the first zone will be when the material velocity is less than velocity of roll. Yes or no? The first part will be when velocity of material is less than velocity of roll. Then velocity of material will become equal to the velocity of roll. And the third phase will be when velocity of material, when the roll throws the material outward, velocity of material is greater than velocity of roll. Velocity of material is greater than velocity of roll. Velocity of material is greater than velocity of roll. These are the three phases. These are the three phases. ठीक है? This phase is known as backward slip. This is known as neutral plane, and this is known as forward slip. Backward slip, neutral plane, forward slip. ठीक है? What is the formula for backward slip? कितना पीछे है? How much it is less than Vr? Simple. Many a time it is asked that it is backward slip. But what is that value? How much it is back? 10%, 20%, 30%? It is less than the roll velocity. Or what is the value of forward slip? How much more than it is from the roll velocity? 20%, 30%, 40%. So what is the formula for backward slip? देखो, velocity of roll minus initial velocity divided by velocity of roll. Is it clear? What is the value of forward slip? Velocity of exit minus velocity of roll divided by velocity of roll. Is it clear? These are the formulas for backward and forward slip. These are the formulas for backward and forward slip. These are the formulas for backward and forward slip. Is it clear? ये पूछा जाता है what is backward slip और what is forward slip, और इनके एक छोटे छोटे अलग नाम भी है, कोजी अपने अपने नाम है. What are these names? तो देखो, this is known as lagging zone. This is known as leading zone. Lagging zone and leading zone. Lagging zone and leading zone. lagging zone and leading zone. Is it clear? Is it clear? This is very very important. This was the basic thing. This was the basic thing. ठीक है, चलो. Please note it down. I am giving you about a minute. मैं 1 मिनट का समय दे रहा हूँ. Please note it down because it will help you to revise in a better way. If you are revising, if you are making proper notes, it will be easy for you to revise. Please note it down, then we'll move forward. चलो, let us move forward then. Let us move forward. ठीक है, अगला एक छोटा सा पार्ट है. ठीक है, we need to understand very very small thing. Now we need to understand about the forces that are included in it. कौन कौन से forces हैं? What are the different kinds of forces? How they are acting and what we can, how we need to understand them to analyze. Then to analyze. Is it clear? तो देखो, सबसे सिंपल चीज है. I am only making one rule for the analysis purpose. This is your rule. ठीक है, देखो, this is your rule. This is the angle subtended from the entry to exit. Let this angle be theta. Theta is known as bite angle. Theta is known as bite angle. बिल्कुल सही है भाई, कोई दिक्कत नहीं है. Now they are asking what are the forces. So देखो, the rule will start applying the force from here. Let us say this force is P, and at the same time the work material is moving in this direction. So in just opposite direction you are going to have mu P. That is the frictional force. That is the frictional force. That is the frictional force. So this thing is clear to all of you. This thing is clear to all of you. This is the basic. These are the two forces that are acting. These are the only two forces that are acting. Okay. These are the only two forces that are acting. So let me draw this as a smaller term. Work material is going, it is getting decreased, and then it will go outwards. ठीक है, कोई दिक्कत नहीं. Here you are applying the load P. Here you are applying the load P, and the work material is moving inside. Now, why work material is moving inside? Can you tell me? The mu will not be in outer direction. That is the catch here. The work material is moving inward due to friction. The work material is moving inward due to friction. So this inward force is only mu p. Due to mu p only, the work material is, देखो suppose I am moving in this direction. Suppose this is the car. If the car is moving in this direction, the frictional force will act in this direction. The frictional forces act in this direction. Suppose this is a platform. Now the car is kept over the platform. Now if the platform is moving in this direction, right side, the car will also move. Why? Because if the surface is frictionless, if the friction between the car and the surface is zero, the surface is moving right, the car will remain like this, but there is a friction. So that is why when the platform will move, the car will also move. The same thing is that as soon as the work material comes in contact with the roll, the friction between the work material and the roll is basically pulling the material inwards. The movement of the material to the right hand side is due to the friction. That is something you need to understand. That is something you need to understand. This angle is theta. This angle becomes 90 minus theta. This angle also becomes theta. Okay, this angle also becomes theta. So if you try to check back the values, this is mu p. So this side becomes mu p cos theta. The downward side becomes mu p sin theta. This is theta. So downward becomes p cos theta, and this side becomes p sin theta. Is it clear? These are the only four forces. These are the only four forces. Those are acting into the material. These are the only four forces. Those are acting into the material. These are the only four forces. Those are acting into the material. समझ में आया? These are the only forces. Those are acting into the material. If these are the forces, if I am saying what is the condition for self entry condition, that is automatically the material gets into the roll. Have you seen that? Suppose you are having a sugar cane. As soon as you put the sugar cane into between the two rolls, automatically it is pulled inside by the roll. You don't have to do anything. Automatically the roll pulls up the sugar cane. ठीक है, जो गन्ना होता है ना उसको आप एक बार में रोल खुद ही अंदर खींच लेता है. Why? That is the self entry condition. Because the friction is so high that the material is automatically entering. So if the material has to enter, obviously your right hand force, that is mu p cos theta, should be more than the left hand force, that is p sin theta. Or you can say mu should be more than tan theta. Yes or no? Because p and p gets cancelled, sin theta by cos theta is tan theta. So mu is greater than tan theta. 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 लिख लो, जल्दी से नोट डाउन कर लो. This is the condition. This is the self entry condition. That is, the friction should be greater than tan theta. If the friction is greater than tan theta, automatically जल्दी से नोट डाउन करो फटाफट. देखो समझ में आ रहा है कि नहीं आ रहा है ये बताओ, आया समझ में, यस और नो? जल्दी करो, जल्दी 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 जल्दी। गुड। एक छोटी सी चीज और देख लो, देखो, इफ बीटा इज द फ्रिक्शन एंगल, अगर बीटा इज द फ्रिक्शन एंगल, you know mu is equal to tan beta. So for self entry condition, can you say tan beta should be greater than tan alpha? Tan beta should be greater than tan alpha or tan theta. Or can you say beta should be greater than theta? Can you say that beta should be greater than theta? Beta should be greater than theta. Yes or no? Yes. Yes, that's it. Is it clear? बेसिक सा था ये। देखो यार, इसके बाद क्या क्या कौन कौन सा पार्ट हमारा कवर अप हो चुका है, सबसे पहले उस पर ध्यान दो। मेट्रोलॉजी इज डन, मेट्रोलॉजी इज डन, दिस कैट कैम वाला पार्ट इज डन, देन योर मेटल फॉर्मिंग इज डन। मेटल कटिंग में थोड़ा टाइम लगेगा बस, दैट्स इट। बाय द फर्स्ट वीक ऑफ जनवरी वी विल रैप इट अप, बाय द फर्स्ट वीक ऑफ जनवरी वी विल रैप इट अप। जल्दी से नोट डाउन कर लो, बिकॉज देखो समझ में आ रहा है कि नहीं, बिकॉज दिस इज इंपॉर्टेंट यार, आते हैं क्वेश्चंस बहुत ज्यादा आते हैं इससे, ठीक है। इसके बाद लिखो, लेट अस कम बैक टू दिस ट्राइंगल, दिस लेट दिस पॉइंट बी ए, let this point be B, let this point be C, and this point be D. Can you say BD is equal to contact length? BD is equal to contact length. Yes or no? BD can be said that contact length. अरे एडिटिव मैन्युफैक्चरिंग करा दिया जाएगा यार, एडिटिव मैन्युफैक्चरिंग कहाँ का टेंशन ले रहे हो? From, very important thing. Thank you, Ankur Kumar. Questions will be solved today from 5 p.m. From 5 p.m. today we are going to have special class. From 5 p.m. today we are going to have special class. And in that special class we will be covering up a lot of questions. We will be covering up a lot of questions. You don't have to worry about anything. चलो करो, फटाफट करो, नोट डाउन करो। BD is the contact length. BD can said to be radius of roll into theta. Yes or no? This is the basic formula for BD. This is the theoretical value. This is the theoretical value. BD is the contact length. अगर अभी कभी आपसे कोई contact length पूछता है, if somebody asks you the contact length, what you will say? If somebody asks you the contact length, what you will say? It will be BD only. It is BD only. That is the contact length. BD is contact length. That is r theta. But sometimes r is not given or theta is, now sometimes it is not possible. या फिर क्या होता है ना, ध्यान से देखो क्या हो रहा है, प्लीज 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 चेक बैक। इसमें ये बताओ, what is the value of CD? Can anybody tell me what is the value of CD? पढ़ा हुआ भूल जा रहे हो तो सिर्फ रिवीजन करो यार, और कुछ मत करो। Practice as many questions as you can, because the more question you practice, देखो कॉन्फिडेंस जो है ना वो सिर्फ और सिर्फ सवाल लगाने से आता है, ये ट्रुथ है। At the beginning you will feel how I can get confidence by practicing question, you will feel that, but once you solve question for 3-5 days now, you will realize that you are getting confidence, you will realize that you are gaining confidence, you will realize. So करो यार, सवाल लगाओ. At 5 p.m. every day I am asking everyone to join me in 5 p.m. lecture. 5 p.m. lecture, I want every one of you to join me. जल्दी बताओ. देखो सिंपल सी चीज है. This is del h by 2. Del h is the change in height. Del h is h1 minus h2. ये जो आपका ड्राफ्ट था ना, this is known as del h. So half will be reduced from top. This is del h by 2 and this will be del h by 2. That's it. Is it clear? So that is why I am saying it to be del h by 2. This small part, that is CD, is nothing but del h divided by 2. बिल्कुल सही है. What is AB? AB is equal to radius. AB is equal to radius. AB is equal to radius. Now sometimes क्या होता है, ध्यान से देखो. Sometimes what happens, del h by 2 becomes very small. If del h by 2 becomes very small, for example, देखो ये, suppose this is the role. This is the reduction, very small reduction is there. So can you say that this part is A, this part is C, this part is D, this part is O? Can you say CD, can you say AC is approximately equal to AD? Because the lesser will be the del h by 2. AC और AD almost close होते जाएंगे. AC and AD will almost become close. Almost come close. AC and AD will almost come close. So that is why when del h by 2 is equal to very small, we will say that contact length is equal to BC. Sorry, A is this. This is B. This is A. So BC. Can you say BD is equal to BC? बिल्कुल आप कह सकते हो BD is equal to BC. You can easily say. How you can say? Because del h is so small that BC and BD are almost equal. Is it clear? This point is A. So that is why contact length instead of BD, BC can also be taken as contact length. BC can also be taken as contact length. Is it clear? तो अगर BC को contact length ले रहे हैं तो ध्यान से देखो कैसे आएगा. Please try to understand. This is your role. This is the entry point. This is the exit point. ठीक है? Let me draw it like this. This is a chord and this is a chord. This is the exit point. ठीक है? Suppose this is the exit point. This point is D. This point is B. This point is C. This point is A. Simple, very, very simple. Can you say AD is equal to R? That is the radius of circle. That is the radius of roll. Just a second. Can you say AD is equal to R? बिल्कुल सही है. Can you say CD is equal to del H by 2? बिल्कुल सही है. Can you say AC is equal to R minus del H by 2? Can you say AC is equal to R minus del H by 2? Or let us say M. Can you say MC is equal to 2R minus del H by 2? Yes or no? MC is 2R minus del H by 2. ठीक है. BC is your contact length. BC we need to find out. Let us say this is contact length L and the other part is also L. So there is a property that whenever two chord intersect, the multiplication of their parts, divided parts, is equal. That is L into L is equal to MC into CD. What is MC? 2R minus del H by 2. MC into CD. CD is del H by 2. Can you say this thing? L square is equal to 2R del H by 2 minus del H square by 4. अब this value will become 0 because del H square will be very small. Because initially only we are considering del H to be small. All this analysis is happening only and only when del H is small. If del H is small, del H square will be very small. So can you say this thing? That is the contact length L. BC is equal to L. This is root over R del H. When del H is very small, then only this value is valid. If del H is small. Is it clear? This formula of contact length is equal to root over R del H. Contact length is BC. BC is equal to root over R del H will be only valid when del H is small. If del H is not small, then the contact length will be BD. It is equal to R theta. It is equal to R theta. Is it clear? It will be equal to R theta. लिख लो. चलिए, ये एक बार हो जाएगा तो फिर हम आगे बढ़ेंगे टू फाइंड आउट what is the force required or what should be the pressure that should be applied by the roll to reduce the size. What should be the you can say the pressure applied by the roll to reduce the size. Is it clear? उसके पहले एक काम करो, एक ये वीडियो फिर से देख लेते हैं. That is the you can say the batches that are going to start from 28th of December on Unacademy Plus. Please have a look on the video. ओके, सो आपने वीडियो तो देख लिया, काफी ज्यादा क्लियरिटी भी आपको मिल गई होगी. नाउ लेट मी टेल यू समथिंग अबाउट द प्लस सब्सक्रिप्शन आल्सो कि प्लस सब्सक्रिप्शन के चार्जेस क्या हैं. आपने लेक्चर तो इतना देख लिया है तो प्लस सब्सक्रिप्शन भी मैं आपको बता देता हूं. दैट देयर इज अ पेड प्लेटफॉर्म दैट इज लॉन्च्ड बाय Unacademy. देयर इज अ पेड प्लेटफॉर्म दैट इज लॉन्च्ड बाय Unacademy, दैट इज Unacademy Plus, where the live classes are going to be conducted. The live classes are going to be conducted. And along with that, crash courses will be conducted to help you revise what you have studied in live class. Your rank improvement batch will be launched so that you can practice as many questions as you can, because depending upon the topics that you have learned in your live class. And when you are ready, you will be giving the weekly test to monitor your progress along with your competitors. And finally, every third lecture will be conducted as a doubt clearing session, and you would be getting the lectures conducted both in English and Hindi. Apart from that, there is a higher order subscription that is offered by Unacademy, where all the benefits of the plus subscription will be provided. But along with that, a personal coach will be provided to you for one-on-one guidance throughout your association with Unacademy. You would be provided with a study plan. You would be provided with a study plan, that is what to study, when to study, and how much to study. Preparatory study material will be given to you so that you don't have to worry about here and there and go here and there on different Telegram channels, YouTube channels, and website to download free material. No, the material will be provided to you and you just have to stick to that material only. Then study booster session will be provided to keep your motivation and the charming level high so that you can attempt the paper with best of your knowledge. And my personal favorite is the personalized test analysis. That is, test giving is very, very important. But along with that test, you should also analyze and you should also realize that what are my weak areas, what are my strong areas, and everything. Okay, chalo. What are the charges? So if you talk about the charges, it is 27,225 rupees for 1 year. After you apply the code crack10, it is 34,650 rupees for 18 months if you apply the code crack10, and 39,600 rupees for 24 months if you apply the code crack10. Okay. What are the charges for Iconic subscription? Iconic is costly as compared to the Plus. Why? Because there are several other benefits as well. So it is 45,225 rupees for 1 year after you apply the code. Now code, any code you can apply, crack10 or Prakhar21, and 66,600 rupees for 2 year. 66,600 rupees for 2 year after you apply the code Prakhar21 or crack10 or crack10. Is it clear to all of you? So these are the charges. This is the batch that is going to be launched. ठीक है, मैंने सारी चीजें ऑलमोस्ट आपको बता दी हैं. The next thing we are going to start from tomorrow is the rolling pressure. What is the rolling pressure? Rolling pressure. Rolling pressure. Is it clear to all of you? ये हम कल से स्टार्ट करेंगे. If you are having any doubt, you can always reach out to me. And this is my profile. You can go to my profile and Academy to follow me and to get all the updates about my courses. You can go to @PrakharShrivastava333. Along with that, you can also follow on us. That is my whole team on the Telegram channel. That is Unacademy ESE GATE. And this is you can say that you can follow us on Facebook as well. That is creatrix.mech. That is creatrix.mech. And the YouTube channels that we are running right now is Unacademy GATE MEPIXE and Unacademy GATE questions. And there are several other channels depending upon your interest. Okay. So I hope that you have learned today's lecture. From 5 p.m. today, 5 p.m. we are going to have the special class. We are going to have special class. We are going to have special classes, and if you feel that you require practicing question, you can obviously join us in the special class where we are going to practice questions from manufacturing and industrial both. Let us meet at 5 p.m. and on 2:30 p.m. tomorrow on YouTube only. Is it clear to all of you? Thank you. All the best. Let us meet tomorrow.